Morning, soldiers. My name is Corporal Dosh, and today I'm going to be teaching you a class on how to convert azimuth. Task number 071-Charlie Oscar Mike-1016. Our overall risk assessment for today is low. Please be cognizant of your water sources that are around. Be careful not to knock those over, spill over, and destroy or damage any of the equipment that we need for this class. Careful for any tripping hazards. A lot of chairs, desks. Make sure that those are placed in the right spot and you're aware of your surroundings, not to trip over those things, wires and such. Please be cognizant of pets in the area. Pay attention to your surroundings and those locations, those pets that are around the training area. Please be aware of paper cuts as they're dealing with maps and other pieces of paper. Be self-aware of those and how to handle those correctly so that we do not end up with any of those injuries. All right, so before I get into my task, I'm going to conduct PCCs and PCIs, so I want everybody to pull out their map, their pencil, paper, ID tags, and water source. At this time I'll go around, I will individually check and make sure each soldier has those things before we hop into this class. All right, I'm going to go over our task conditions and standards for today's class. Again, converting azimuth, task 071-Charlie Oscar Mike-1016. Conditions: you are a member of a squad preparing to conduct tactical movement, and you have been directed to convert azimuths in preparation for that movement. You have been given a 1 in 50,000 military map with a declination diagram, pencil, paper, magnetic azimuth, and a grid azimuth. Some iterations of this task should be performed in Mach 4. And today, we're not going to be performing any tasks in Mach 4. Standards: convert an azimuth into back azimuth, a magnetic azimuth into grid azimuth, and a grid azimuth to a magnetic azimuth without error. All right. Note: the north-south lines designate grid north on your map. The compass needle points to magnetic north. The grid magnetic GM angle is the angle difference between grid north and magnetic north. So on a map, you have those lines that run north and south. That determines where grid north is going up. Your compass is going to show magnetic north, which, depending on where you are, is going to be a lot different than what the grid north is on your map. Warning: when converting azimuth into back azimuth, extreme care should be exercised when adding or subtracting the 180 degrees. A simple mathematical mistake could have disastrous consequences. So we're going to go into converting an azimuth into back azimuth. So with that being said, as I just said in this warning, with your 180 degrees, if you are a little bit off and you're back azimuth and you're trying to get to where you came from and you're 1 or 2 degrees off with your math, well, you could end up in a completely wrong location as to where you're trying to get to. Even if it's just by 1 degrees, if you travel 10, 15, 20 miles, you're going to be a significant amount of distance off of that azimuth if you do not pay close attention to your math when converting back azimuths. So you will add 180 degrees if the azimuth is 180 degrees or less. Fairly simple. Subtract 180 degrees if the azimuth is 180 degrees or more. So you're adding, if your azimuth is 180 degrees or less, and you're subtracting if your azimuth is 180 degrees or more. So I want to give you guys a quick example. If the azimuth is 45 degrees, adding 180 degrees, it would be 225 degrees. So if you were at 45 and you were trying to get to where you came from, it would be 225 degrees, would be your back azimuth. If the azimuth is 270 degrees, and you would take away 180 degrees, that azimuth would then be 90 degrees. All right, going on to converting a magnetic azimuth to grid azimuth. So what you're going to be doing is you're going to be taking magnetic, which is your compass, where your needle's pointing, and you're going to be taking that azimuth and you're going to be putting it on to a grid azimuth, which would be on your map, using your protractor and whatever method you choose to do that. To convert a magnetic azimuth, to grid azimuth, you will be subtracting the GM angle. And I'm going to show you guys what a GM angle is in that declination diagram in just a second. Warning: when converting azimuths into back azimuth, extreme care should be exercised when adding or subtracting the 180 degrees. A simple mistake or of 1 degree could be significant in the field, like we've already mentioned. It's the same thing when you're converting azimuths from magnetic to grid, and if you're converting from grid to magnetic, you have to be very precise in paying attention to the GM angle that I'm about to show you guys, and your azimuth that is on your compass as to where you need to go. The declination diagram shows both a graphic picture of the GM angle and provides a written summary of the GM angle. This written summary includes the date of the GM angle and the actual angle in both degrees and mils, because if you're doing land navigation, you're probably going to be using those degrees as your azimuth, and other parts of the military and different MOSs, you're going to be using mils, depending on what your situation is and what you're trying to do. So that's why they have both of those things on there. All right, locate the GM angle, which is part of the declination diagram at the bottom of your map. And I'm going to show you guys that figure right here. So this right here, up here, is your map, as you can see, with your grid squares and lines and all that fun stuff. Right here you have the grid north, which is what is shown based upon those north and south grid line that goes up your map. That is going to be your grid north. This right here is going to be your true north, as demonstrated. And this is your magnetic north right here, which is 9.5 degrees for this specific figure. And then you have your mils right there. All right, so you will then determine whether the GM angle is easterly or westerly. So that means this right here is pointing easterly, and it could be westerly also. And I'm going to get into how to properly identify those things and what you're going to need to do when you do that. All right. Identifying an easterly GM angle, which is right here. We identified that this is a easterly GM angle, and a westerly GM angle is going to look like that. It's maybe hard to see, but that's what it's going to be. All right. Apply the mathematical formula to convert a magnetic azimuth to grid azimuth. Add the easterly GM angle to a magnetic azimuth to obtain a grid azimuth. So I'm going to go over a quick example, but it is very important that you pay attention to your math when you're converting these two things. So you're looking at it, you're like, okay, this is 9.5 degrees, and so you're going to be adding that GM angle, trying to obtain from magnetic to grid. You're going to subtract the westerly GM angle from a magnetic azimuth to obtain the grid, as shown, these two things here. As an example, given the magnetic azimuth of 190 degrees using the above diagram, which is 9.5 degrees as your GM angle, you would add that 9.5 degrees to 190 degrees to obtain a grid azimuth of 199.5 degrees. All right, we're going to go on to converting a grid azimuth to a magnetic azimuth. Locating your GM angle, which is part of the declination diagram at the bottom of your map, as already stated. And the declination diagram shows both graphic picture of the GM angle and provides a written summary of the GM angle. This written summary includes the date of the GM angle and the actual angle in both degrees and mils, as has already been stated. Applying the mathematical formula to convert a magnetic azimuth to grid azimuth, subtract the easterly GM angle from a grid azimuth to obtain the magnetic, and add the westerly GM angle to a grid azimuth to obtain a magnetic azimuth. As an example, we're going to use the exact same outcome we used from the last figure, and we're going to use it now, but we're going to be taking it away. So as an example, given the grid azimuth of 199.5 degrees, using the above diagram, you would subtract this 9.5 degrees from 199.5 degrees to obtain a magnetic azimuth of 190 degrees. So if you had 199.5 degrees on your map, and you wanted to get wherever you were going using your compass, dead reckoning, or however you're choosing to do this, you would then subtract that 9.5 degrees, ending up with your magnetic azimuth, which is what your compass would be, of 190 degrees. All right, at this time, we're going to have a 5-minute practice. And during this 5-minute practice, I'm going to give you guys 3 azimuths in which you're going to perform all 3 performance steps I'm about to give you on all 3 of those azimuths. Is that clear for everybody? All right, cool. You will take all 3 of these azimuths I'm going to give you, and you're going to convert an azimuth into a back azimuth. You're going to take a magnetic azimuth and turn it to a grid azimuth, and a grid azimuth to magnetic. So prepare to copy. Your first azimuth is 78 degrees, second's 165, third is 200. And during this practice, I'll be going around, walking around. I'll be answering any questions soldiers have. I'm making on-spot corrections, making sure they understand the performance steps for the evaluation to come. Excuse me. All right, I would now, now that the practice time is over, I would now brief the squad on the evaluation procedures. I would restate my task conditions and standards. Conditions. You're a member of a squad preparing to conduct a tactical movement, and you have been directed to convert azimuths in preparation for that movement. You have been given a 1 in 50,000 military map with a declination diagram, pencil, paper, a magnetic azimuth, and a grid azimuth. Some iterations of this task should be performed in Mop 4, which today, like I said earlier, we're not going to be doing any iterations in Mop 4. Standards. Convert an azimuth into a back azimuth, a magnetic azimuth to a grid azimuth, and a grid azimuth to a magnetic azimuth without error. Soldiers, this is very imperative. If you have any error on any of these performance steps, you'll be a no-go for the entire class. All right, at this time, I would conduct a before PCCs and PCIs, ensuring everybody has their pencil, paper, map, water source, and ID tags, and making sure they have all those things, again, going around physically touching, make sure they have everything they need for this evaluation. And then I would carry on with that evaluation, not giving any soldiers any answers, and that would start the evaluation. All right, evaluation is over. I would state the number of trained proficient soldiers and then untrained soldiers to my SGL. At this time, we have 6 soldiers untrained and 1 trained, and that person is myself. I would then identify our location for retrain and that uniform, which would be tomorrow at 0900 in our current duty uniform, OCPs, with all the equipment that you need, your map, pencil, paper, ID tags, and water source. And then, as just mentioned, I would now conduct an after PCCs and PCIs, and I would fill out my pre-combat inspection checklist and make sure that every single soldier has that stuff without any loss or damage to it. I would annotate that on this list. I would then review my risk assessment, filling out blocks 13 and 14. I would then conduct an AAR. In my AAR, I would state what was supposed to happen. And what was supposed to happen is teaching them a class on how to convert azimuths. That's exactly what's supposed to happen with the task conditions and standards of teaching them how to convert an azimuth into a back azimuth, of magnetic to grid, and grid to magnetic. And I would then ask the soldiers what actually did happen based upon what was supposed to happen. I would ask that, what did happen? I would then ask what went right. I would then ask what went wrong. And how do I improve training for next time? And I would state that the rules and goals for this AAR is everyone has the right to speak, and I want to encourage everybody maximum participation. Do not talk over each other, and always have respect for others' differing viewpoints. All right, and then I'd also ask if there were any injuries or damaged equipment. No injuries or damaged equipment. I would then ask if all control measures were implemented effectively for my risk assessment, and they were. I would then check my paperwork, and as I check my paperwork, I would then ask those soldiers to conduct a police call. And during the checking of my paperwork, I would then state, based upon what is asked after my AAR, all controls were effective, and I would state that in my DD form 2977. I would also fill out my hands-on evaluation DA form 5164R for all soldiers. And then I would, okay, all that paperwork is checked out, and I would then tell them, I would restate that the retrain evaluation, just to remind them, make sure they have all they need. I'll remind them of what they need. I would then release them to their team leaders, and after that, I would do my own walk around, making sure that no one left anything, make sure that we had all the equipment that we brought out here, and keep it all together for our retrain and re-evaluation for tomorrow. And at this time, I'd like to close out my training site.